Okay, for section 8.4, we're going to talk about something called compound interest. This is very different from what we talked about in section 8.3, which was simple interest. So what you need to remember about simple interest is simple interest is calculated based on just the principal amount that's initially borrowed or initially invested. So if you borrow $10,000 to buy a car and you have an interest rate of 6%, you're going to pay 6% of $10,000 every year you have the loan. Okay? With compound interest, things are a little bit different. With compound interest, each time you calculate interest, so if you did this annually once a year, you're not just calculating interest on what you initially borrowed or invested. You're calculating interest on what you initially borrowed and invested, plus any interest that has accumulated over time. Okay? So before we dive into any like actual calculations of compound interest, let's just sort of play around with what we already know about simple interest, but tie it into this new world of compound interest. Okay? So first of all, let's kind of remind ourselves when we were back in section 8.3 and we were talking about calculating the future value of an account. So the value of an account after some point in the future, we had the formula A equals P times 1 plus RT. So what I have here in this table is we're going to have a scenario where we're going to invest $1,000 at an interest rate of 5%, and we're going to look at it annually. So we're just going to let T equal 1, okay? And we're going to calculate interest for just 1 year to start with, okay? So this right here is P when we do this one annual simple interest calculation. So what we get is A is equal to P, which is 1,000, that's what we're starting with, times 1 plus R, but remember, R has to be a decimal, so 0.05. And then T, we're just going to calculate it for 1 year, so T is 1. So we get A equals 1,000 times 1 plus 0.05. And if you were to type that into your calculator, you would get 1,050. And you can see that laid out right here. So what that means is in 1 year, if you have $1,000 sitting in an account that's earning 5%, you're going to have $1,050 in that account at the end of the year. You've earned $50 in interest. Well, in year two, instead of calculating your interest on just that $1,000, we're going to say, hey, guess what? You have that $1,000 plus that $50 in interest you earned last year. So we're going to make your starting balance $1,050. Okay. And then we repeat the whole process. So now we're going to say, okay, P is 1,050. We're still going to calculate interest for just 1 year at 5%. And after 1 year, your new balance is going to be $1,102.50. So that means we didn't earn $50 in interest this year. This year we earned $52.50. And it's kind of like, well, where in the world did that $52 come from? If I took 100 or $1,102.50 and I subtracted what I started with, which for year two I started with 1050, that would give me $52.50. So just thinking kind of in terms of interest, year one I made $50 in interest, but year two I made $52.50 in interest because my balance was a little bit higher. Okay, so now what's going to happen is for year three, if I use the simple interest formula, P is no longer going to be 1,000. It's not going to be 1,050. Now it's going to be $1,102.50. So all of that interest that is accumulated is going to be my new starting balance. And then I do the same simple interest formula, $1,102.50 at 5% for 1 year, and my balance would now be $1,157.63. So if we did the same thing, let me do it down here, $1,157.63, subtract what we started with, we would have $1,102.50. So let's do just a quick calculation. 1157.63 minus 1102.50. And we earned $55.13 in interest. Okay, so you can see here kind of in red, year one, we earned $50 in interest, and that $50 was added to the account, and then we recalculated interest with this new balance. The second year, we earned $52.50 in interest, so a little bit more than the previous year because our balance was a little bit more than the previous year, and then that was added to the account. Year three, we have 2 years worth of interest added to the account, and then we calculate, and in year three, we made $55 and $55.13 in interest, and then that's added to the account. So then for year four, My starting balance is no longer $1,000. It's $1,157.63. And then if we use the simple interest formula again at 5% for 1 year, our balance would then be $1,215.51. So if we figured out how much interest we earned in year four, we would take that balance and subtract what we started with in year four, which was 1,157.63. Let me do a quick calculation here. And it looks like in year four, we earned $57.88 in interest. So you can see here with compound interest each year, the interest is going to be more and more because the balance is growing each year. Okay. Now this works out for you really well if it's an investment. If it's like a car loan, maybe not so much, but that's kind of the idea behind compound interest. Now, would you want to do all of this work just to calculate a future balance for 4 years? No, of course not. So we have formulas that basically do all of this for us. So we have some initial present starting value, and then we calculate interest, but every time the interest is calculated, it's getting added and that p-value is changing. Okay, so interest each time it's calculated is being calculated on a bigger and a bigger and a bigger account. Okay, so again, we're not going to have to do all this work separately. We have just one formula that'll do it all for us. Okay, now let's get to a definition. Hopefully that helps you kind of understand the idea behind compound interest versus simple interest. Now, compound interest, we have interest computed on the original principal amount as well as any accumulated interest is called compound interest. So again, you're not just calculating it on that initial starting amount. Each time you calculate interest and add it to the account, you're calculating interest on the principal plus any interest. So it gets bigger and bigger each time. Okay. Now, the number of times, and this is really important, I'm going to use this terminology here a bunch. The number of times interest is compounded per year is called the compounding period and is denoted by a lowercase n. Okay? So what you'll notice with compound interest is you're not necessarily calculating the interest just once per year. Okay? With simple interest, we calculated the interest once per year. You basically paid some percentage each year. Okay? With compound interest, interest can be compounded multiple times a year. Okay? And the number of times per year the interest is compounded is called the compounding period. So some terminology that you definitely need to familiarize yourself with. If interest is compounded annually, we would say that n is 1. Okay, interest is just calculated once a year. If interest is calculated semi-annually, that means it's calculated twice a year, and we would use n equals 2. You're going to see our formulas in just a bit are going to have n's in them from now until really the end of the chapter. So n is that compounding period. Okay, quarterly means interest is calculated 4 times a year, monthly 12 times a year, weekly 52 times a year, and then daily you have to be really, really careful with. In the banking world, and I do not come from a finance world, so I'm just telling you the basics that I know. But in the banking world, daily can be two different things. Daily can be what we would consider daily, 365 days a year. But there's also something called the banker's rule, where if interest is calculated daily, it is actually going to have a compounding period of 360. And the very, very brief understanding that I have of this is that there are certain national holidays that don't count in the 365 days. So there's basically 360 days that they consider interest to be calculated. I don't know a whole lot of details about that, but as you read through the book, be careful. If they say just daily, you're assuming 365 days a year. If they say daily with the banker's rule, N would be 360. So just use a little caution if the compounding period is daily. Okay. Now, in the previous section, we had a few videos, and I told you in those videos that you need to be really careful with your formulas. If you are in the face-to-face class, I'm going to give you a handout with formulas. If you're in the online class, I'm going to post a handout in Moodle with the formulas. However, if you don't have access to a printer or you lose the handout that I give you, keep your formulas in one place. Like have this one sheet that you make with your formulas on it, okay? So specifically for the online class, you don't want to have to flip back and forth through the notes trying to find the formula that you need. So keep all of your formulas written on like one sheet of paper so you can easily access your formula sheet. And that is if you don't want to print the formula sheet that I have in Moodle, okay? So the formula for future value for compound interest paid in times a year is as follows. It's a little bit messier than what we're accustomed to, but that's okay. We have calculators, okay? So I want to remind you that A is future value. P, it can be thought of as principal, but we typically think of it more as like present value. So it's like how much you would have today. R is the interest rate. So think interest, think R for rate and interest rate. And remember, when we put this into the formula, we always put R into the formula as a decimal. T is time, and we always think of time in years unless you're very specifically told otherwise, and that is very rare. So time is years. And then N is the number of times interest is calculated per year. So we kind of call this just the compounding period. All right, so let's look at two examples. All right, so example one, it says here you deposit 4,200 in a savings account that has an interest rate of 4%. So we already know P is 4,200. We know R is 4%, but don't forget we write it as a decimal, so 0.04. And then for part A, it says if interest is compounded quarterly, how much will you have after 10 years? Well, T is easy, it's just 10. And then we have to figure out what our compounding period is. And the compounding period tells us how many times the interest is going to be calculated per year. And if interest is calculated quarterly, there are 4 quarters in a year. So interest is going to be calculated 4 times a year. Therefore, N is equal to 4. Now, when it comes to showing your work, I am perfectly happy for you all to use a calculator. In fact, you don't want to piece these formulas together and do a little bit here, a little bit here, a little bit here, and then put it all together at the end because you'll have round off error. What you want to do is find a way to type these formulas into the calculator all at once. But as far as showing work is concerned, what I insist on seeing is the formula filled in with numbers. So I can see if you've got the numbers in the right spots. That helps me figure out where errors are being made. So we know that we have the formula A equals, we're up here, A equals P times 1 plus R divided by N. So you take your interest rate, divide it by whatever N is, and then you raise that stuff in parentheses to the N times T power. Okay? So we're going to get A equals P, which is 4,200, times 1 plus R over N, so 0.04 divided by 4. And then that stuff in parentheses is going to be raised to the 4 times 10 power. Now, these are definitely easiest if you have a graphing calculator, though not totally required. It's going to be easiest, so I'll definitely show you how to do this on the graphing calculator, but you certainly have other ways to get these answers. I would never require you to get a graphing calculator app on your phone, but you could if you wanted to. All right. And we can play around with other ways to get the answers. So let's go to the calculator. Right here. Maybe. Yeah, there we go. Okay, so we want to type this formula in. We had P, which is 4,200, and then parentheses. Again, parentheses are above the 8 and 9 buttons on a graphing calculator. And we want to type 1 plus R divided by N, and you can just type in R division N, it'll be fine. So we had 0.04 divided by N, which was 4. End your parentheses. And then to get to that exponent world, we need to type in the caret button. So if you look above the division button, there's like the little up arrow, kind of looks like the roof on a house. You want to click that button. That's going to raise you to the superscript world. And we need N times T. N was 4 and T was 10. You could certainly just type in 40 here. I usually just type the numbers in all at once, but you could just do 4 times 10. Sometimes it's not easy mental math, but in this case it is. All right, so we have 4,200 times 1 plus 0.04 divided by 4 raised to the 4 times 10 or 40th power. And we always round 2 decimal places unless we are told otherwise. And we want to round mathematically unless we're finding P. So here we're going to round mathematically. So we have $6,253. And then we have 0.227. That second 2 is in the hundreds place. So we look 1 digit to the right of that. We have a 7. That tells us to round up. So I'm going to make this $6,253.23. This one mathematically rounds up. Okay? So we had, let me get to my notes page because I will forget these numbers before. There we go. So $6,253.23. So that is how much would be in your account in 10 years. Okay. Now, part B says find the interest earned in the account after 10 years. Well, how on earth would I find the interest? Remember, interest, you don't have to do the simple interest formula. So interest is equal to the future value minus principal or present value. I'll generally think of it as present value, but sometimes I'll flip-flop between present value and principal. So what is our future value? Well, it's $6,253.23. Our present value was 4,200. And once I subtract those, we get, let's see, I get $2,053.23 in interest. So once you make your initial investment, anything in excess of that is going to be interest. So you take the present value, subtract it from the future value, and you get how much interest you earned over the course of 10 years. Okay? So you earned $2,053.23. Okay, let's do one more example. So let's scroll down a little bit. For example 2, it says you deposit $25,000 in an account that has a rate of 3.5%. If interest is compounded monthly, how much will you have after 20 years in whatever this account is? So let's see. P we know is $25,000. I said thousand funny. R is 3.5%, but for us, we're going to write it as a decimal, so 0.035. T is 20. And then remember, N is the number of times interest is going to be calculated a year. And it'll say something about interest being compounded and then give you some time frame. Interest is going to be compounded monthly for us. There are 12 months in a year. That means interest is going to be calculated 12 times per year. Therefore, N is 12, okay? Now, in case you forgot, the formula is A equals P times 1 plus R over N raised to the NT power. And remember what I told you in the previous example, as far as showing work is concerned, I want to see the formula filled in with correct numbers, okay? And then you can just use a calculator to do the actual calculation for you. So P is 25,000 times parentheses 1 plus R, which is 0.035, divided by N, which is 12, end your parentheses, and then raise all of that to the 12 times 20 power, okay? And then we can just go to a calculator from here. So let me swap screens. All right, so we have 25,000 as P, and then in parentheses, we're going to take 1 plus R divided by N, so 0.035 divided by 12. I then want to raise that. Remember, we're going to use that caret button, which is above division. I want to raise that all to the 12, that's N, times 20, which is T, so that's the N times T power, and then hit enter. And again, we're going to do some rounding here. We have $50,292, and we have 0.55087. Well, the second 5 after the decimal is what we're rounding to. Directly to the right of that is a 0, which tells us to round down. So we're going to leave this at $50,292.55. Okay? So let's go back to the worksheet. Okay, so we have $50,292.55 in the account. I will tell you, you have to be very cautious when you're investing money. It's usually very, very low interest rates. So don't think in 20 years you can double your money necessarily. You'd probably get an interest rate less than 3.5% when you're investing. When you're borrowing, different story. Okay. Now, part B again says the same thing. How much interest will be earned in that account after 20 years? So all we have to do is take the future value and subtract the present value, and that gives us the interest. Okay. Well, the future value is $50,292.55. The present value, or the principal that we started with, was $25,000. When we subtract those, we get $25,292.55 in interest. Okay, so when you do these problems, make sure you read them carefully, make sure you answer the question asked, and know how to play around. So like this question asked how much is in the account, but also know how to find the interest that you earned on that account. Okay, And in the next one, yeah, so that's it for this particular topic. So get an understanding of how compound interest works. What we never want to do is all of this work that we did up here in this table. We want to plug all this information into one formula and calculate it once, and it does all of this behind the scenes work for us. This table is just to give you kind of an understanding of how compound interest works. Make sure you understand the different compounding periods. Make sure you get a formula sheet that you're making, especially for the online class. Make sure you start making your own formula sheet so you're not frantically flipping through pages trying to find the right formulas, and certainly know how to use that formula. Okay. In the next video, we're going to talk about something called interest that's compounded continuously.